This is Algebra 2 Prerequisite Skills on Factoring. So we are going to be factoring each of the following. If it's not possible, we will write prime. Now, for the first day, we are just going to factor by greatest common factor, difference of squares, and sum and difference of cubes. We're going to start off by looking at the greatest common factor. This is always going to be the first thing you do whenever you have to factor, is you want to figure out what the greatest common factor is between it. Now, that word factor means we want to break it down to everything that it's made up of. So, for example, if you were to factor 15, you go, okay, well, 15 is 3 times 5. So the factors of 15 are 3 and 5. If you wanted to factor, say, 18, go, okay, well, 18 is 2 times 9. But 9 is 3 times 3, so the factors of 18 would be 2 times 3 times 3. So 2, 3, and 3 are all factors of 18. That's essentially what we're doing, except for now we're going to have expressions. So there will be variables in there as well. So we're going to be looking for the greatest common factor in these, otherwise known as the GCF. So for our first example, z to the third b squared plus 2a squared b. We want to take a look and decide what the greatest common factor is amongst these. So if you look at both of these individually, you notice that they both have a b in common. So we're going to take one of those b's out. So then in parentheses, what we're left with is z to the third. We took one b out. It was b squared, so we have one b left. Plus 2a squared. We took one b out. There's only one b there, so that's it. So that's factored. B, and then in parentheses, z cubed b plus 2a squared. Notice that the remaining values in here, there is no more common factors left. All right, second example. Negative ab minus ac minus ad. So we have to look at each term and decide what the greatest common factor is. They all have an a in common, and they're all negative. So we'll take a negative a out. If we take that out of the first term, we're left with a positive b. Out of the second term, we're left with a positive c. And out of the third term, we're left with a positive d. So that factors down to negative a times b plus c plus d. Now, if you ever want to check your work for these, you just have to distribute whatever you took out and make sure you get what you started with. So if you distributed that negative a through, you'd have negative ab minus AC minus AD, which is exactly what you started with. So if at any point in time you're unsure if you did it correctly, just check your work by distributing whatever your greatest common factor was. Let's do another one like this. Negative a squared y squared minus a squared y minus ay squared. So we have to look at each of these and decide what the greatest common factor is. So if we just focus on a's, we have an a squared, and an a. So we have one a in common. Now if we look at the y's, we have a y squared, a y, and a y squared. So we have one y in common. They're all negative, so we're going to take out a negative ay. So if we're taking out one a and one y and the negative sign. So from this first term, we would have a positive. We'd have one a left and one y left. Plus, second term, we would just have one a left, because we took that y out. It's out in front. And third, ay squared. The a we took out. From y squared, we only took one out, so we have one y left. So there is our factored version. All right, we can also factor by something called difference of squares. Difference of squares is exactly what it sounds like. We should take the difference of two perfect squares. When you factor by difference of squares, it always factors down to the same thing. So if you have a squared minus b squared, you have to figure out what the perfect square of a squared and b squared are, which is a and b. And then one is plus, one is minus. It's going to factor like that every time. So this is kind of your formula you can think of for difference of squares. Now I'm going to show you why this works. So if we have a plus b times a minus b, and if we were to simplify this, we'd want to distribute the a to both. So we'd have a squared minus ab. Distribute the b to both. So b times a is plus ab. B times negative b is minus b squared. Negative ab plus ab cancel, and we're left with a squared minus b squared, which is exactly what we started with. Okay. So here, if we have 16x squared minus 9y squared, and we want to factor this. It's a difference. These are both perfect squares, so we'll split it up into its two parentheses, and we need to figure out what the perfect square of each is. 16x squared is a perfect square of 4x. 9y squared is a perfect square of 3y. And then you make 1 plus, 1 minus. So 16x squared minus 9y squared factors to 4x plus 3y times 4x minus 3y. All right, let's say we have 81 minus y squared. Once again, we notice that we are taking the difference, so we're subtracting, and they're both perfect squares. So we'll split it up into its two parentheses. 81 is a perfect square of 9. Y squared is a perfect square of y. Make 1 plus, make 1 minus. So that factors to 9 plus y times 9 minus y. And if at any point in time you want to check to make sure you did that correctly, go through and actually multiply them out, and you can double check your work. We can also have the sum or the difference of two cubes. Sum of two cubes, or the sum of cubes, would be like if we have a cubed plus b cubed. Those are both cubes. This will factor to a plus b times a squared minus ab plus b squared. That is your formula that it will always work, and we'll just come over here and check it quick. So if we want to check this, we first have to take the a and distribute it to each. So a times a squared is a cubed. A times negative ab is minus a squared b. A times b squared is plus ab squared. Now we'll do the same with the b. B times a squared is a positive a squared b. And notice I lined it up beneath here because they are like terms. B times negative ab is a negative ab squared. Once again, I lined it up with its like term. And b times b squared is a plus b squared. These middle terms here cancel, and we're just left with a cubed plus b cubed, which is exactly what we started with. So if we want to factor out the sum of cubes, we need to figure out what each of these are the perfect cube of. So y cubed is a perfect cube of y. 125 is a perfect cube of 5. Now if you don't just know that, there's a button in your calculator that looks like this. And you would type in cubed root, that button, and then 125, and it'll come out as 5. Okay, some of your calculators will require you to put those in the reverse order. I would suggest you try it a few times with your calculator to see which way yours works. All right, so we know that our a term here is like our y, and our b term is like our 5, and we just can follow that equation. So a plus b, y plus 5, times a squared, y squared, minus a times b, y times 5, 5y, plus b squared, so 5 squared is 25. And we wouldn't write it as 5 squared, we want to write it as 25. So y cubed plus 125 factors to y plus 5 times y squared minus 5y plus 25. Similarly, here we have a cubed minus b cubed. This would be a difference of cubes. And this factors very closely to the sum. They're just off by a sign. So here this would factor to a minus b times a squared plus ab plus b squared. And once again, we'll come over here and we'll distribute it out, and you'll see that this does indeed work every time. So we would start by distributing the a. So a times a squared is a cubed. A times ab is plus a squared b. A times b squared is plus ab squared. Distribute the negative b. Negative b times a squared is negative a squared b. Once again, lining it up with its like term. Negative b times ab is negative ab squared. Lining it up with its like term. And negative b times positive b squared is negative b cubed. These two middle terms cancel, so we're left with a cubed minus b cubed, which is exactly what we had started with. So this is the correct formula to follow for when we're factoring. So let's say we have 125x cubed minus 64y cubed. We need to figure out what the perfect cubes are. 125 is a perfect cube of 5, and then x cubed is a perfect cube of x. So that is like your a term. 64 is a perfect cubed of 4, y cubed is a perfect cubed of y, so that is like your b term. So a minus b. So 5x minus 4y times a cubed, or a squared. So we have to take the 5x and square it. So we have to square both the 5 to get 25 and the x to get x squared. So we'd have 25x squared plus a times b. 5x times 4y. Well, 5 times 4 is 20, and then xy. And then b squared, so we have to take the 4y and square it. 4 squared is 16, y squared is y squared. So plus 16y squared. So 125x cubed minus 64y cubed factors down to 5x minus 4y times 25x squared plus 20xy plus 16y squared.